Hello Year 12, and we're back here with exercise 3C, the third of our videos here for logarithmic functions. Now that we know that the differential of the log of x is 1 over x, we can all of a sudden mix it up with a whole lot of different functions now. So we're going to differentiate these things. We'll see how it works. Now, dy dx equals differential of x is just 1, and the log of that is 1 over, plus, where the equals come from, plus 1 over x. That's not very complicated. Over here, not much more complicated. dy dx. Differentiate this part and I get 10x. Now, the 7 is constant, so it's just minus 7 over x. Righto? No need to go any further than that. Differentiating functions including the logarithmic function. Now we've got a couple of other things here. We can use the chain rule here to satisfy ourselves that these basic forms work. So I'm going to say u equals ax plus b for du on dx equals a. I know that. I'm going to say this is y equals. Therefore, y equals the log of u, y by du equals 1 over u, which is, of course, 1 over ax plus b. Yeah, I should have given myself a little bit more space. Oh, I've got a little bit more space. So, y by dx is y by du times u by dx, which is equal to 1 over ax plus b times a equals a over ax plus b. What does that mean? If I have this form here, the log of ax plus b, right? The coefficient of the x term goes up the top, and this function here goes down the bottom. Nice, look at that. Now this one's going to be, well, slightly more complicated, but not too much so. Again, I'm going to say u equals x squared plus 1, so du on dx. Du on dx equals 2x. Y equals, see, I've used log base e here. Let's write that again, right? Don't be fooled into thinking there's something different. They're not. Log base e of u, so du equals 1 over x squared plus 1, just to speed things up. That means du dx is 2x, right? The differential of that part of it there over x squared plus 1, just like that, right? Not hideously complicated. So that's pretty handy. We can do more complicated things, and you can rely now on not using the chain rule to do this stuff. You get this thing here, you just know differentiate the inside part here, goes up the top, and this part here goes down the bottom. Nice. There is a third case here. And it's a bit more complicated. It's very helpful, but it's a bit more complicated. That sometimes we need to do a little bit of massaging to get it to fit that form. But anyhow, we can use the product rule and the quotient rule. We've done these things before. Now, what we need to do here is I'm going to have 3x squared log of x plus x cubed over x. And that sort of tidies up a little bit in that cancels out there. I get a 2, and I get x squared outside of 3 log x plus 1. Looks good enough to me. Wonderful, and here we go. We're going to have to use the quotient rule here. Be careful. It's late, I'm tired, and it's easy to get this wrong. So I'm going to say that u, I'm just going to write these things down. U is the log of 1 minus x. V is x, u prime is negative 1 over 1 minus x, which, just to get rid of that negative, I'm going to multiply the top and bottom by negative 1, right? Multiply the top by negative 1, right? Let's say the negative's up there, and it becomes a 1. Multiply this by negative 1, I get x minus 1, right? Equals 1 over x minus 1. Just a bit tidier there. And v prime equals 1. That's good. Now, down dx. Oh, geez. Down dx. That's untidy. I should have written that there. Down dx of the log of 1 minus x over x equals. So, v u prime x over x minus 1. Okay, so this one here times this one here, this one minus vu prime uv prime. So this is the log of 1 minus x times 1. All good. All over v squared. I should have said here v squared equals x squared. All over x squared. Now, can we tidy that up a little bit more? No, look, I think that's probably pretty good. Is that okay? I'm not thrilled by it, but yeah, I don't think it gets too much better. Okay, it's going to do us. Very good. So, product rule, quotient rule. Let's see. I did mention here that... oh, no, that we've got a third case that's a bit more complicated. That's fine. The video's not too long yet, but this is something reassuring. We can use log laws to make things easy for ourselves. So let's see how that works. In this case here, this is the same as, this is the same as 2 times, oh, no, it's not. No, this is the same as, come on, the log of 7 plus the log of x squared. Equals the log of 7 plus 2 log x. Right? That's how our differential, how our log laws work. So down dx of the log of 7x squared, which is what we want to do, is the differential of this. Now that's a constant. Gone. This one here, 2 over x. Beautiful. That's far easier. It's much nicer. And again, we did the same thing here. So this is going to be equal to 5 times the log of 3x minus 7. So if we differentiate that, down dx of the log of 3x minus 7 to the 5 equals, right, that 5 stays here. I get 5 times the differential of this times 3 over this, 3x minus 7 equals 15 over 3x minus 7. Right? Nothing super exciting about that. Now, what are we doing here? This looks like it's going to be horrible, but it won't be. So this is the same as the log of 1 plus x minus the log of 1 minus x. Now differentiate this, and I get 1 over 1 plus x. Differentiate this, you're going to get a minus. Differential of this is negative 1, so I'm going to change that to a plus. 1 over 1 minus x. And that's pretty nice. I wouldn't go further to try to add those things together. I would leave it just like that. And that is the end of our third video. Hope you enjoyed it. See you in class.